about the founders here and a little bit about your project as well.
So, this one wasn't working, is it?
Good afternoon, everyone. I'm Brendan, co-founder of MASA. At MASA, we're building a decentralized data scraping network. You can think of it a little bit like Scale AI, but for decentralized companies. We serve Fortune 500 companies and Asian networks with scraped data, whether it be from Twitter, public web, sources like Telegram, Discord, and YouTube and podcast content. We annotate this, label it, structure it, and feed it up to companies so they can train models, use it in RAG, and various other machine learning applications. Great to be here this afternoon.
Hello, I'm Neil, founder and CEO of Reddio. We are doing a parallel EVM powered by GPU. I'm also a guest lecturer at NTU, so this is my place, teaching blockchain scalability. Nice to meet everyone here.
Hey everyone. Hey everyone, this is Jasper, the CEO and co-founder of Hyperbolic. I did my undergrad at Peak University, graduated with highest honor, student of the year, and right after that I went to UC Berkeley for my math PhD. I finished my math PhD in 2 years, which makes me the fastest person to finish a PhD in the history of Berkeley when I was 24 years old, and also give me the idea of the name of my future company, Hyperbolic, because I was doing hyperbolic geometry and topology. I also won a few gold medals in various mathematical competitions, and after that I worked at Citadel Securities and Avalabs, the company that built large blockchains, before I founded Hyperbolic Labs. So at Hyperbolic, we believe the future of AI is collaborative. We're building an open AI ecosystem economy that allows different people to contribute, participate, and benefit from what they actually contribute from. We're currently building the infrastructure level of this vision, and including like decentralized orchestration layer, AI inference service, and verification layer.
Hello, hi. My name is Jialin. Here, okay. Yeah, so I already introduced HETU earlier in the morning in the keynote talk, so I'll give a very quick overview. So I'm co-founder of HETU protocols. HETU, we're building infrastructure to support heterogeneous option systems currently targeting AI, where the goal is to provide both fair attribution and fast finality.
Okay, so there comes the first question of our panel. So, well, as we understand, actually Web2 giants has built many successful AI infrastructure, AI application. Okay, thank you. Yeah, and AI applications as well. So, do you think Web3 AI and decentralized AI makes sense? And what's the logic we apply here? Maybe we start with Brendan.
Okay, so I think anywhere where you're looking at coordinating systems through economic incentives, blockchain or decentralized technology makes sense. I think there are broader applications that I'm sure other panelists will talk about, but for me specifically, I think that when you have a coordination problem, solving that coordination problem by aligning incentives through game theoretical models makes the most sense. Like BitTensor does a really great job of this, especially when it comes to subnets and the way that subnets either thrive or die. And it's constantly driving a continuous improvement cycle where you see exponential scaling of whether it be data services. We have a subnet on BitTensor, subnet 42, and we incentivize miners to aggregate and structure certain data sources on the subnet. And this just simply wouldn't be possible without a decentralized network to run the economic layer on. So from my perspective, coordinating, bringing alignment, and we can talk a lot about alignment when it comes to AI, not just with incentives, but other philosophical matters. You can really do this effectively on this programmable incentive layer.
To myself, I'm not really biased to whether the application makes sense or not because we are a platform. But what we really want to make sure is the infrastructure is ready for these kind of AI applications. where when we look into the market right now, there's no company really running a network with GPU network, especially on layer 2s. That's where we actually transcode all the output from EVM to CUDA instruction. And so that any AI applications, for example, if they want to deploy the AI inferencing with a blockchain smart contract onto layer 2, they can do it now. We see a lot of companies deploy token-related applications and activities on the blockchain for AI companies before to incentivize the community to do more, like a modeling contribution and all those work. But we don't see so many companies bring the model itself, the logic itself, to any blockchain yet. So that's what we have been building for. If you are happy and want to embrace this kind of network, we are here for you guys.
Yeah, so we believe that AI is one of the most powerful tools known to the mankind. And in the future, AI will be integrated with the most important systems like transportation, social media, like robotics, finance, even your brains, right? And in a centralized environment, AI, right now, like as an individual, you have no chance to be part of the control group of these advanced technology, and there's also no chance for you to participate in the revenue sharing opportunities. And so by building on-chain, leveraging blockchain, we're able to let different individuals, including you guys, to be able to contribute and benefit from it, and that's how we think like blockchain can help.
All right. Okay. So I think if you want efficiency, Web3 is never the solution. Right? So I mean, you can always find centralized solutions that is significantly better than whatever you do in a decentralized environment. So everybody understands that. I think that also applies to AI. Right? So if you just want to run the biggest model, you just want to have the fastest inference, you probably still want to go for the centralized Web2 kind of scenarios. So I think decentralization of Web3 provides additional benefit, things like security, things like fairness, things like participation, things like fair incentives, and privacy. Right. So I think these are the main additional benefit we can have. So I think that's also the things we currently focus on some of our infrastructures.
Understood. Right. So with all the benefits that Web3 technologies bring, so the next question is actually for Jialin. So at HETU protocol, I understand that we focus a lot on privacy-preserving computation. And as this computation becomes more complex and integrated to the decentralized AI systems, how do you see these privacy concerns being addressed by HETU protocol?
Oh, okay, thanks. So at HETU, we are not particularly focusing on a specific computational paradigm, right? So we're looking at many different kind of heterogeneous computational schemes. Right, but our overarching hypothesis is that we are focusing more on the relationship between different events happening in the system, be it computation, being messages, being transactions. The fundamental similarities across all of this is that there is a causal dependency between everything. Right? So I think that's based on, if you believe in causality. Right, so and then what we do is that we establish this causal ordering, or causal relationship among any kind of computation or process, intermediate results, and the final outcome. And then we leverage this to be able to define what are the causal relationship between any of your events, and then we're able to do things like to preserve the value of users, to understand the contribution of the participants.
Right. Thanks, Professor Jialin. So the next question is actually for Brandon. MASA integrates decentralized identity and fair AI into its network. And how do you see computational advancements accelerating the adoption of decentralized identity? And what are the key user cases that you see, particularly in DeFi and other sectors?
Yeah, so it's interesting. We started off at MASA looking at decentralized identity initially, this notion of being able to share data privately with any party, the same way that Apple is approaching giving you personalized AI on your phone. And we realized through the course of time that there was a bigger opportunity to unlock other data sources more broadly for training and making a large, vast, permissionless and open source set of data for anyone to use. You can access a lot of our data through Hugging Face or indeed through a bunch of APIs that we have through our network. And it just unlocks a whole host of opportunity for AI developers, specifically around getting current, up-to-date contextual information into an agent or into a model. O1 that was released last week, already if you go and look at current topics, current papers that have been written, you'll not be able to kind of get any insight on those art or the papers or the work that's been done to be able to get it to view. You'll have to inject that using RAG through a document system, or you have to pre-train or distill the model down. So we make all of these different data sources available at scale, not just specific from an identity perspective, to really unlock what we think are the eyes and the ears for agents in the future, having these real-time, not governed or owned by anyone, open channels for data that can feed these groundbreaking systems.
Right. Okay. So the next question is for Neo of Reddio. Reddio offers parallel EVM layer 2 solutions to scale decentralized applications. Could you explain what advancements in computation are influencing blockchain scalability and improve the overall performance?
Yeah, so that's really what we. Hello. Yeah, that's what we really has been working on for the past 3 years. The team background is actually. The team had been working on distributed database in the past. We built the most high-performance distributed database globally, ranking #1 in the past called TIDB. When we start to work on the Reddio for the past 3 years, we definitely understand the difference between the centralized database and the trilemma for blockchains. Always trying to balance off those trilemmas from our team. Recently, we saw a lot of parallel EVM only talk about the performance, where basically they are on the good direction to build another database, which you can definitely use it. But when you're considering security and also the decentralizations, that's a big piece actually. That's where from the beginning we are focusing on decentralized node operators on layer 2. Even for that is actually pretty new. Not mentioning we are adding a GPU on top. So all we do here is to make sure the security is there, and also it is decentralized. May not be that decentralized compared to layer 1 because layer 2's work is really to scale the network. But now we are able to support at least 20,000 transactions per second. But at the same time, we are working with all the researchers from NTU and US to accelerate further on the state process itself, where we are able to enhance another 5 times. So imagine this kind of performance with security and also decentralization in place. We are here for any decentralized applications. A lot of investors asking us or customer asking us, does the DApp really need this kind of performance? I think this is like a chicken egg issue. If you have a good performance network, you will see many different applications. Because right now when we talk to a lot of DApp developers, they are actually limited by the high latency for the network. That's where they can't put a lot of logic on top, like AI modeling, right? How can you imagine doing AI modeling on a decentralized network? As Jialin just mentioned, you have a centralized database to solve the issues, but we do see some of the values there for putting the data modeling on the decentralized network. For example, you can see the transparency, right? Just very simple examples. That's where we have this network ready right now. AI is definitely one of the sectors we currently are working on with our partners and customers. At the same time, we are also working with some other popular network stack, for example, Audiobook. Have you heard of Audiobook-based decks? Majority of the decks are based on AMN, right? So with that, right, you can actually do that to really kind of hit to the level of the experience of centralized exchange. So that's what we have been working.
Okay, so the next question is for Jasper. Yeah, so with computation accelerating innovation comes several challenges in the industry, such as scalability, cost efficiency, etc. So what are some of the key challenges that you believe is crucial for the industry to overcome for decentralized AI to move forward?
Yeah, so I mean, Hyperbolic is building the infrastructure to support all decentralized AI protocols, and we think there are three major problems we need to solve. First is building a scalable system that can aggregate global GPUs, and then build AI services that can harness the power and maximize the potential of different kinds of GPUs, including NVIDIA GPUs, AMD GPUs, Intel GPUs, etc. And second is verification, which is that how to make sure that the results are correctly generated, even if it's run by a random third-party node. And lastly is the privacy problem, which is how do you protect users' data, even if it's handled by a random third-party node. And so for the first problem, which is the scalable system problem, we are building a decentralized orchestration layer powered by our Hyperbolic distributed operation system. So basically, as long as you install the software and run it on your cluster or your computers, your clusters or computers can seamlessly be integrated with our network. So users on the demand side can very easily to access all the computes in our network. And we're also building our special compilation stack. We call it Hyperbolic compilation service that can compile different AI models into different low-level hardware language, like CUDA for NVIDIA, ROCm for AMD, etc. And we can achieve the state-of-the-art performance of running AI models on these different hardware machines. And for the verification part, we invented a new verification mechanism called proof of sampling, which is a sampling-based verification mechanism that can verify the correctness of results with very low computational overhead. And then for the privacy part, we are using TEE, which is Trusted Execution Environment, that try to protect users' data on the hardware level.
Okay, cool, thanks Jasper. So the next question is actually open to the panelists. So we are seeing technologies like FHE or variation of it, TFHE, and actually Dan Bonnet also wrote about the single T, TFHE technology as well. And what impact do you think they would have in terms of privacy preserving in decentralized AI?
Okay, so I'll answer first. I mean, there are various privacy preserve methods to protect users' data when running AI services. Like FHE is one example. TE that I mentioned is another example. So FHE is like fully homomorphic encryption, which is try to protect the user's data while being able to do the computation on a software level. That one is I think still in progress. Like right now, the computational level is around like 1000x. So I'll say that's still a long way to go before making it very practical. And then for TEE, I think this is very practical technology. According to NVIDIA, it only reduced the computational speed by 1 to 2% when you run AI inference, and it slowed down the computation speed for training by 50%. So I think like a lot of like AI projects are trying to use TE for their solutions, but for TE it depends on the hardware's like guarantee, right? If NVIDIA try to add a black dot into the hardware, then there's no way that you can prevent that by using TEE. However, for FHE, because it's secured on the software level, so theoretically, no one can actually add a black dot to that solution. So I'll say FHE is more secure, but it takes a long time to actually become more practical.
Right. Any other the panelists have to share in terms of privacy-preserving technologies?
Oh, okay. I think there's a fundamental trade-off between security or privacy in this case and performance. I have faith in the scientific community to keep improving efficiency of schemes like FHE, but our opinion is that if you want FHE to be as fast as just general compute, it's impossible, right? So you still pay the price, right? So it depends on the application. I think it's very application specific and user specific. If you have users that really require the kind of security, they will probably be okay with paying a little bit of performance overhead. In this case, a lot of overhead. But there are also a ton of users who are okay with slightly lower security. So the benefit of this community is that we provide many different kind of solutions on this spectrum, and then users can choose based on their need, right? It's similar to the L1, L2 case, right? So there are users who are okay with the L2 solutions, even though they are slightly less secure. And there are users who absolutely want the L1 security, so they choose the slightly lower, right? So I think we just need to present to them all the different possibilities and they can choose.
Right. Okay, and here comes the last questions of our panel. As AI and blockchain continue to evolve and emerge, regulation becomes a challenge to us. So what do you see as computational advancements helping to address or comply with the regulation challenges? And what do you see as decentralized AI builders will face in the near future?
I may not be the right person to ask this question to, because we fundamentally believe that everything should be open and available to everyone. I'm in the space for a very long time and very much a maximalist when it comes to freedom and open participation in these systems. So I think regulation is healthy in certain domains. However, what we can do in terms of computation, I think technologies like TEE, trusted execution environments, can be very interesting when it comes to verifying specific code that's running or verifying certain computation that's done in a way that will build trust with government organizations that are, for example, in Europe or the UK, starting to imply and put on people more rigorous regulation. But I do think that it needs to be done judiciously so as we don't hold back progress. And we as founders need to build systems that can in certain respects maybe govern or regulate themselves. And what I mean by that is having incentive mechanisms that make it adversarial to behave in a way that's not compliant or not for the benefit of the broader system. This can be done on an economic level, which I think can be much more interesting than setting concrete walls and certain hard systems and rules that can ultimately hold back progress.
Yeah, so I think this, again, an issue a lot of company has to face from our perspective when we build a network, because when for the blockchain, right, the most important piece is really computation integrity itself, which if you translate a little bit more, it's regulation resistance, right? But that's the purpose how the blockchain is designed. We just follow the pattern and design based on that. That's where we build this decentralized network, and that's where we use zero knowledge proof to scale at the same time, making the whole thing fully regulated for the network itself. But at the same time, we are trying to see from a network perspective, how can we work with the government? So we are actually part of the FinTech Association in Singapore. We talk to the government on a regular basis. However, we get a sense from network itself is basically impossible for us to work with the government on the regulation basis, because when you zoom into the regulation terms, they are talking more about individual users, how they treat, how they perform, how they behave, where you need a KYC process to start everything. And for a decentralized network, that's basically really conflicting. So we just follow as much as we can. But to our customer and partners who are operating to the users, either here or other places globally, we just try to provide our connections to the government and help them to overcome these kind of regulation issues. That's what we can do the most right now.
So yeah, so when it comes with regulation, there are many things that can be regulated. So for example, like privacy is one thing, right? GDPR, like all these different stuff, which I think like FHE, all these privacy preserve methods can help. And then there is another one which is like the IP regulation, like can you use the data from Reddit, from Twitter, like for training, and or like use like New York Times for training, and how do you like acknowledge the ownership, like try to pay for using the data? I think this is how crypto can help actually, because if you can have this transparent ledger to record the whole AI pipeline, like what kind of data you use for training this model, do you use like human feedback to kind of improve the model, and then like if you kind of using the blockchain to record all these transactions, and then every time when the revenue that coming to this model can be distributed back to the contributors, I think that can somehow solve the IP related legal questions. And so I think there are many different questions in terms of allegations, and people are being creative in the blockchain AI space, and we look forward to seeing more and more solutions leveraging blockchain to solve the AI problems.
Okay, I think I agree with all of the panelists. Maybe just to add on, I think a blockchain or a decentralized systems does provide open information. I think that is a benefit in terms of what